Okay, now we are. Okay, Aaron, you're good. That's good. Okay, so the My Open Math page here, there's a couple things I changed on here or added on here that I want to show you. The first thing, speaking of recording, is I added this purple videos line. So right now, this videos line has that Zoom meeting from last Tuesday. I think it's only the second half of it, but it's on there. The Zoom meeting from last Wednesday. And we missed uh, Thursday. I was having technical difficulties. So that, oh, hi, Martin. Uh, I was having technical difficulties on Thursday, but I did make a video on lines, um, trying to take um, 2 points and make a line thing, but look at it from a little bit of a different perspective than you've maybe seen it before, probably seen it before. And then I added this this morning. The word problems in the linear section tend to be where people get the most stuck. And I had a nice, this is an old video, just about, I think it's only 10 minutes long or so, but working a truck problem. It's a nice particular word problem from your chapter 2 material. I think I can actually even play this. Yeah. Can you guys hear that, by the way? Hear the audio from it? No? Okay. There's a way to do that, but I'm not getting that tech savvy yet. I'm learning. But you can watch that video. Yeah, it's exactly 10 minutes long. If you want, it's a nice word problem. Get to draw some diagrams. And just some helps setting up. It's just an example word problem, but I do spend some time in it talking about kind of word problem methodology, good ways to start looking at and start thinking about word problems. So I'm going to keep adding videos onto here. I am recording this today. As long as I don't forget, or Crystal doesn't forget to remind me to record these, I'll post them here afterward. It takes a while to have the computer process the file into an MP4 and then get it uploaded. So that takes a little while. It won't be up automatically, but it will get up there. Also, if there's something that you guys are asking either in the forums or just sending me emails that's like, I should make a video about that, I can make a video, and that's the place I'll post them. Fair? So I tried to make it purple, kind of bright purple, so you guys would see it, but that's where I'll post of videos specifically for us. So that's one of the new things. We'll talk about that hand-in homework. A lot of you guys were asking about that. I do have a plan for that today. It'll be hopefully super, super easy and quick. We'll see how that goes. But I did want to show you, I added in the homework problems 2 links down here. The message my instructor about the question should have been there always, but some of the homeworks didn't have it. So if you click on that, it will send me a message and have the problem written in it. So I can see, okay, this is what you're playing with. This is the particular problem you're working on. You can get this from, I think there's a link up in settings somewhere where it can force, oh, it's on the student view, but where you can force that to happen. But this just puts a nice link down there. So you can just hit that, it'll send me a message. The big thing I'm adding, or I added that I hope will help, is this post this question to the forum. So a lot of you guys were referencing questions that you were working on the forum and trying to write out the whole question, or say it was, section 1.6 number 5, then everybody's got to go, not only got to go look for that problem, but also it can be a little different depending on the randomness of the questions. So being able to just directly post this question to your forum is really handy. It should I'm going to stress that, should be set up so that it goes to the correct week. If it doesn't go to the correct week, let me know. I tried to set all that up yesterday so you guys could post these easier. And so hopefully the weeks are all lined up with the proper questions. But if they're not, or you find they're not, let me know. So hopefully that'll make sending that information out a little easier. Before we talk about the hand-in homework, any questions about any of that? I gotta move this over here. Okay. Any questions about any of that? That makes sense? Yep. Okay. In terms of the hand-in homework, at some point today, make sure you've got a paper and pencil, and preferably your smartphones, if you've got them, handy, because what I want to do today with the hand-in homework is just, at some point today, I'll have you guys do a problem, and what I want to do is kind of practice just that. How do I send in stuff? There's a lot of different ways you can get the handwritten work in. Because we're going to use that for scratch paper and scratch work and partial credit and stuff on tests, and the department did decide a policy of we need to have scratch work, copies of scratch work for your tests. I want to practice and make sure we're all relatively comfortable sending documents in. Okay. We'll talk more about how that will work as a test procedure later on, but I just want to make sure we get used to that. Okay, how do I get documents onto my OpenMath so I can see them? Cool. So we'll talk about that. Well, let's actually, why don't we do that right now? So I need to grab that. Okay, so where'd that go? Oh, there it is. So I don't want to make this complicated, but I do want to have it be useful for the discussion we're going to have today. So let's just take, we talked about, let's do it that way. So I want you to write down what the square root of 9 is equal to. Don't spoil it by telling everybody what the square root of 9 is equal to. The square root of 9 is equal to something, and I'm going to write it here. And then with your phone, anybody need to go grab their phone real quick? And if you don't have a smartphone, there are other ways to do this. This is just the kind of the easiest one. Gotta get my brain to work. Managing 3 devices. 4, 1, 5. Okay, so you've got that written down. You've got your phone. Oh, I gotta get this other camera to work for a second here. I knew this was going to be fun. That's why I wanted to do it together. Hey, did that come up? Cool, scary thing. Okay, so I've got my answer. Right or wrong, we'll talk about it. And going to get into my phone. Now, there's lots of apps that you can use to scan documents. I grabbed Cam Scanner because it was available and nice. There's a trial version and there's a free version. If you just kind of skip all the things about premium version, it'll stop bugging you about it. There is an option right now for educators and students to get a free premium version just because of all the stuff going on. So you can, but you have to register with your school email. But don't worry about that. But you'll just have to have some sort of scanning software. And actually, frankly, we'll talk about you don't need to have that. I lost connection to that. So there's lots of different scanning documents. Still, okay. Lots of different scanning tools. This is just one of them. But so, for example, I'm going to use that to take a picture. I have to pick this up a bit here. Take a picture of my page. And for this particular software, notice that's a terrible picture. It's at a weird angle. And there's a big shadow in it. It's a pretty bad picture. But this software is nice because it straightens it out, flattens it out, and tries to take out any messiness. If you don't have a comparatively nice scanner software, don't worry about it. I'll show you some other tools that you can use. But if we save that, and oops, I know this isn't great to see, but if we save that, and then yeah, I'm going to turn that into a PDF and share local. Again, this will be on the line so you can watch this again if you want to. So I shared it as a PDF, and then I'm going to go over to My Open Math just on the phone. Most of the scanning software will allow you to email it to yourself if you find that easier. But you can get to My Open Math and do all the My Open Math things and the Zoom things, by the way, on your phone. Go to the class. I'm going to go down to the hand-in homework. And it'll say print something off. That's, the other hand-in homeworks will have something for you to print off and do. This one, I'm just having you do this paper. But this upload file here is what you're going to be using to put that document into My Open Math. So I'm going to hit that choose file, and it's going to give me, this will happen no matter what software you have. This is just from My Open Math. It'll give you 3 choices there. Notice one of them is camera. You can literally just use that camera to take a picture of your single piece of paper if you want. The benefit of using the scanner softwares is that they usually come out a little bit better, a little bit clearer, and most of them have the ability to do multiple pages in a much easier way. So the scanning software is nice, but if that causes you trouble, you can just use camera for it. But I'm going to go into files, and depending on what kind of phone you have, navigating these files will be a little bit different. But we are 9/13 is when I took that picture, so that PDF. So now it's got the cam scanner 09/12/40. So at 9/12, this when I took that picture. You can of course assign it a name in the software. I'm just trying to do this really fast. Submit it, and uploaded that, submitted. And it will stay red until I get a chance to check it off. So I know that was really super fast. Now, again, if you use a different scanning software, a different type of phone, or scan it with if you've got a printer or scanner at home and don't want to use a phone or don't have access to a phone, there's a number of different ways we can get this to work. You can even transfer image files into, say, a Word document or something, or upload them as image files. There's lots of different ways you can do that. That is a bright, shiny light on that, isn't it? Lots of different ways you can do this. What I want you to do today for this homework assignment 1 is play with the tools and figure out for you and your setup, what you have available, how you want to go about setting that up. Okay? And you can send me, again, this question, this square root of 9, or you can send me really anything. Just today, you've got, I think, those 14 hours left. Sometime in the next 14 hours, figure out how to send a document. If you have trouble with that, or if it doesn't work out, don't stress. We'll figure it out. But I just kind of want to everybody try to do that and see how that goes. Oh, that was a fast 10 minutes, but questions about that? Does that make sense? Play with it, but let me know if that gives you any trouble. So the only thing I want for that hand-in homework this week is a document sent, so we learn how to use that tool. All right, I'll go back over to that whiteboard. So for the square root of 9, I had on my sample page what I put 3. But does anybody want to suggest or confirm that they think that's the answer, or suggest a different answer? Yes, that's the answer, or yes, you want to suggest a different answer?
That's the answer.
That's the answer. Anybody say anything different? It's good not to, because indeed the square root of 9 is 3. The common answer that we sometimes get in a fight about is, some people want to say the square root of 9 is plus or minus 3. But the square root is a function, and the rule about functions, what makes a function, is that one input gives you one and only one output. So the square root of 9 is indeed 3. It's not plus or minus 3, it's just plain 3. The issue comes in when we start trying to solve things like x squared equals 9. So this was just evaluate the square root of 9. This is an entirely different process, because this is solving. Fair? Here we would evaluate the square root function. Functions have one answer, that's the answer. If you tried to solve this equation, what would you get as a solution? Type that in the chat. I keep wanting to say comments. They're not comments. So type in the chat what you think the solution set is to that. So that we're all happily saying plus or minus 3. Good, because you're right. The solution set to this is plus or minus 3. But how do we do that? A lot of folks, and not incorrectly, will go, okay, I want to take the square root of both sides of that. If we take the square root of both sides of that, again, what's the square root of 9? Well, we set up here what the square root of 9 is. The square root of 9 is 3. You all said that quite happily up here, right? What is the square root of x squared? Tell me either.
Plus or minus x.
It's not plus or minus x, actually. Because again, that square root is a function, so it's only allowed one answer, right? And plus or minus x is two answers. So it can't be plus or minus x. What else you got? Good, Aaron, absolute value of x. This isn't just x. That's what most people want it to be. The square root of x squared is x. But the square root of x squared is not equal to x. And you might think, well, yeah, but if I have, say, the square root of 4 squared, the square root of 4 squared is 4. So the square root of that thing squared ended up being that thing. But the counter example, if I have the square root of -5 squared, we know -5 squared is 25. The square root of 25 is 5. We did not get our input back. We didn't get our -5 back. Our x didn't stay x. It also didn't become both +5 and -5. So it's not plus or minus. All that happened is that x value's negative, if it's there, it gets stripped off. If there's not a negative there, it just stays the same. And that is our definition, quite correct, Aaron, of the absolute value. So we're still left having to solve something here. What values of x make the absolute value of x equal to 3? Well, positive and -3 both make the absolute value of x equal to 3. So the important part here is that this square root is not generating the plus or minus. We often think, and quite reasonably, we often go from this step, that was a weird arrow, from this step directly to x equals plus or minus 3. And there's no reason not to just go directly to that step. But it's important for us to remember that that square root of 9 is not what's generating the plus or minus. And that this, more importantly, that this square root of x squared isn't x. That this square root of x squared is an absolute value, and that absolute value is what's generating the plus or minus. Fair? So this is just a little kind of detail about something that's going on kind of behind the scenes here, and why we have to be careful about this distinction. When are we just taking a square root, and when are we using the solving technique? Because it's that solving technique that's really generating that plus or minus. So why are we talking about that? We're talking about that because our goal this week, or the first couple days this week anyway, is to talk about solving quadratics. And you remember quadratics from Math 95 and Math 65, or their equivalents. So a quadratic is anything of the form ax squared plus bx plus c. That's a quadratic equation if it can be written in this form. The only rule here is that that a value cannot equal 0. You can imagine if the a was 0, we would just have a bx plus c, and bx plus c is a line, not a quadratic. So this a can't be 0. The b can be 0, the c can be 0, the a can be anything but 0, but you have to have a non-zero x squared term for it to be a quadratic. And one of the things we want to work on, want to kind of remind ourselves how to do, is solve quadratics. So let's, we already solved one, the x squared equals 9. But let's jump into something a little bit more complicated. Oh, I'm even going to put a 3 there. Minus 2 equals 10. Got all kinds of fun. Now, we could approach this or solve this problem in a couple of different ways. A lot of people coming out of, particularly coming out of Math 95 and Math 65, often what people want to do is take this and start multiplying all this out. They'll FOIL this out and get, the 3 times x squared minus 10x plus 25 minus 2 equals 10, and distribute the 3, get 3x squared minus 2 equals 10. Subtract that over, move the 10 over to say it equal to 0, and then solve that once it's in that form. You can hopefully tell by how I wrote that, I don't want to do it that way. It works, but it's long, it's time consuming, and there's a lot of mechanics in there. Really, the nice thing about this particular setup is we have this nice perfect square term here. There's no other x's outside of this x that's right here. So a much easier and more direct way to solve this is to just isolate this x minus 5 squared and take that square root. And I'll show you. So if we add 2 to both sides, 3 times x minus 5 squared equals 12. Divide off that 3. Oh, that's even a nice 4. X minus 5 squared equals 4. Once we get here, once we get to the x minus 5 squared, instead of having to FOIL that out and set it equal to 0 and use a whole bunch of other tools, we can get rid of this square just by doing the same thing we did with the x squared equals 9. Take the square root of both sides. We end up with x minus 5 equals plus or minus the square root of 4 is 2. Again, technically there's a step in between here if we want to be super formal, where we have the absolute value of x minus 5 is equal to 2. That's where that plus or minus is coming from. But we usually don't write that. We just know that that plus or minus has to be generated because we took the square root of both sides. And then we could finish it off. Add the 5, add the 5. We get x equals 5 plus or minus 2. So x is equal to 7 and x is equal to 3. Questions about solving a quadratic that way? It's referred to as square root method because we use a square root to do it. It does require this to be a nice perfect square here, but we'll find out that that's not actually as restrictive as it may seem. So I'd like you guys to take a minute and, let's say, I got to give you something with icky fractions in it, don't I? Yes, right. Icky fractions are great. I thought so too. So that's essentially, it's got some fractions in it, but it's the same basic, oops, it's also got a negative in that radical. Can't have that yet. Well, we could. You guys have done complex numbers in your background somewhere, but let's change that. So we're not going to do complex numbers yet. So following this methodology, take a moment and solve that for x. When you've got some x values, give me either a thumbs up or a got it, or express your joy and happiness in some way. Anyone fighting the temptation to multiply all this out? It's usually not too hard at this stage to convince people that multiplying all this out is not worth your time. You don't want to multiply all this out. It's a pain. I know, fractions. It'll make everybody unhappy. But once we've isolated that squared object, take that square root of both sides, and we get a nice x plus 1 equals, again, plus or minus from the absolute value here, square root of 3 over 2. Now we can talk a fair amount about what we want to do with the square root of 3 over 2. You guys remember rationalizing though, right? We really do want to rationalize stuff in here. It's a good habit to get into. So if we multiply the top and bottom of that by the square root of 2 over the square root of 2, we'll get a nice square root of 6 over square root of 2 times square root of 2 is 2. So that'll turn into a nice x plus 1 equals plus or minus the square root of 6 over 2. Now, a quick note about rationalizing. In Math 95 or in Algebra 1, depending on where you took the prerequisite material, you were taught how to rationalize. Oftentimes, exactly why we rationalize can get a little bit lost in that. And to me, there's really one big reason why we rationalize. Anything that you do with fractions, you want a nice clean denominator, because we often like to cancel denominators, simplify denominators, clear denominators. Anything you're going to do with a fraction is easier if the denominator is nice. So really, handing somebody an answer where there's a radical in the denominator is just rude. You're saying, here, you clean this up. Just why would we do that? You know, like, could we give somebody an answer that's, 6/4? Sure, we could. But they look at us like, who raised you? Right? You're going to reduce that because that's the nicest form to give somebody the answer in. It's not because the square root of 3/2 is wrong. It's just an ugly form to work in. Now, there are going to be times where we're not going to care, and times where it's like, actually, right now, that square root would be easier, so we're going to leave it alone. But in general, by habit, rationalize your fractions because you're good, polite people, and you were raised properly. For example, when we subtract this 1 from both sides, we get that nice x equals -1 plus or minus the square root of 6 over 2. And if we want to perform this addition and subtraction, if we want to bring this together, turning this into 2 over 2, so we get common denominators, is much easier with that nice rational 2 down there. Negative 2 over 2 plus or minus square root of 6 over 2. That's much easier to do if it's rationalized. Negative 2 plus or minus the square root of 6 over 2. It's a much nicer form. Well, not necessarily all that much nicer than this. It's arguable, but nicer to perform that addition subtraction with the nice clean denominator. Fair? Do be careful about reducing here. We can't divide those 2's out because the 2 can't divide into the square root of 6 because that 6 is under the radical. So there are lots of little places in this answer for reducing issues to happen. So be careful about your strict order of operations in terms of cleaning up your fractions. So, okay, that one was a little bit uglier than 7 and 3, but a lot of our answers are going to be ugly. It turns out in the world that there are vastly more irrational numbers. That square root of 6 is not a perfect square, so that those numbers are irrational. And there are a lot more irrational numbers than rational numbers. So in lots of applications, in lots of practical applications, you expect irrational numbers all the time. So start being happier with that. A lot of people get nervous if they get an ugly looking answer and they go, oh, I must have done something wrong. Most of our answers are going to look like this. Our problems are going to be less rigged to be nice. Does that make sense? Get some yeses there. Good. Okay, so questions about that problem before we start looking at how to handle it when things aren't quite as nice. Guys all happy? Crystal, you look a little like, You're muted.
And they're just, fun answers that go all the way down with fractions. That's all.
Yeah. Well, and fractions are often an issue. Even at this stage, frankly, even by the time you get into 112 and calculus, there are often a lot of students who just, they want to work in decimals, they don't want to work in fractions. And in a lot of ways, that's totally reasonable. It makes sense to want to use decimals instead of fractions by habit. But I got to tell you, it's so much harder. Working with fractions is truly much, much easier. And one of the things I often use to kind of make that point is, I'm going to go off and do it here in orange because I feel like it, is I'll often take, people who are like, I like decimals, I don't like fractions. I'll say, okay, all you decimal people, take 0.125 and multiply that by 0.25. What'd you get? Okay. While you're working on that, fraction people take 1/8 and multiply it by 1/4. What'd the fraction people get? 1/32. Anybody get this done yet? This is hard. This is a tremendous amount of work. But it's dependent on something we know how to do. Fair? It's something you practiced a whole bunch in elementary school. The only difference is the fact that we got to carry around that decimal point, so we'll have to, figure out how many decimal values we have. But we didn't have to learn anything too tremendously extra to handle this scenario. but the actual mechanics of doing it are pain. You'd say, oh, I just grab a calculator. It's harder to grab the calculator than do it this way. And if you didn't know, 1/8, this 0.125 is the decimal equivalent of 1/8. The 0.25 is, of course, the decimal equivalent of 1/4. These are the same problem. But which one of them is easier? Now, I'm going to argue that this one is easier to do, but which one of these was harder to learn how to do? I'm still going to say this one. Fractions are much harder to learn how to work with properly. They are weird. They don't act like everything else does. They're strange until you get really used to them, until you master them. But why do we still use them if they're so much harder to learn? Because they are so much more powerful. They're so much easier to use once we're good at them. Last point on that, often the analogy I give is I ask, is it easier to drive from here to New York? Not that any of us can go anywhere right now, but is it easier to drive from here to New York or fly from here to New York? Arguably, it's easier to fly. But which is harder to learn, how to drive the car or fly the plane? It's a lot harder to learn how to fly a plane. Fractions are the same way. It's much harder to get good with working with fractions. But the benefit is, once you do, you can fly. I know, that's the corny part. Isn't that horrible? So don't shy away from the fractions. Embrace them, dive into them, use them. If I put an example down that has a bunch of fractions in it, go, yay, flight school, because it really will make your work so much more powerful. So I know that's kind of a long spiel, but particularly for those of you going into 112, if your fraction skills are not solid going into 112, they will be solid when you leave, because everything is fraction work in 112. You know, I've seen people kind of scrape by 111, like with, you know, I'm not going to work in fractions. You have to anyway, but, you know, I've seen people try to drag their feet. You hit 112, you can't. You simply can't. Fair? So, embrace them. I feel the need to give a big, nasty fraction problem now. But I won't, because I want to do something nice. So, problems like this, we could really, you know, change these numbers all we want. As long as it's in this form, this process is really going to be the same. Isolate the squared object, square root both sides, move over any constants, and we'll solve it. The trick is, what happens when we're not in that nice form? So let's say we still have a nice problem. Say it's x squared minus 8x plus 5 equals 9. I want 9? Sure, 9. Why not? Using this methodology won't work in its current form. If we did, you know, say just try to isolate that x squared, we'd have 9 minus 5. Is 9 minus 5? 4. 4 plus 8x, and say square root both sides and get x equals plus or minus the square root of 4 plus 8x, which we could simplify a bit, but this won't work as a solution because that x is still in there, right? We can't solve for x in terms of x. So that kind of basic methodology won't work. We've got to change that up a little bit. It would have been really nice if this had a perfect square in it instead, right? Well, one of the most important principles you'll ever learn in mathematics is called the wouldn't it be nice principle. it would be nice if instead of being this x squared minus 8x, it would be nice if this was instead a perfect square like this one was, or like this one was. So the way we solve these when they don't have perfect squares in them is to make it into a perfect square. I'm going to take this thing and transform it into a perfect square so we can use this solving methodology. And not only am I going to claim that it's a way to solve it, but I'm going to claim and pretty firmly stick to the claim that this is the only way to solve this. Now, you might believe that, you might not believe that, but we'll talk. So what do I mean by make this into a perfect square? Now, perfect squares look like, well, like these did. The x plus a quantity squared. That's what we want to build. So what does that have to look like in its foiled out form, in its form with the x squared and the x? Well, if we multiplied this out, if we foiled that, we'd get x squared, we'd get a times x, and another a times x, so you'd have that 2ax, and then a times a, so plus a squared. We talked about this last week, the square of the first, twice the product, square of the last, right? So all perfect squares look like this. So if we want this to be a perfect square, we have to make it into this form. How do we do that? Well, what do we have? We have an x squared. Good, because we needed an x squared. This term has to be 2 times something, x. Is this negative 8 2 times something? Well, it's 2 times negative 4, right? Well, what if it wasn't an 8? What if it was a 6? Well, 6 would be 2 times 3, right? What if it was a 7? Well, 7 is 2 times 7 halves, right? Everything is something times 2. It just might not be clean. So to figure out what this a is, whatever this term is, or whatever this coefficient is, in this case it's negative 8, we want to divide off that 2 to reveal what that a value is. In this case, it was negative 4. Again, if this was a positive 13, then this would just be 13 halves. Fair? Anything can be divided by 2. It doesn't have to be pretty. Then this last term, notice, is the square of that a. So can we take that negative 4 and square it? What's the square of negative 4? I can hear you all thinking, positive 16. You're absolutely right. So if we add 16 onto this, I'm going to leave that plus 5 because we didn't do anything with it, equals 9. If we add 16 to this, this is a perfect square. Now, of course, we can't just willy-nilly add 16 to anything we want. If we add 16 to this side, we had better add 16 to that side as well, right? That's our whole add. You can add something, but you got to add the same thing to both sides. Now, this x squared minus 8x plus 16 factors as a perfect square. We know it does because we just built it to. Not only does it factor, we know how it factors because it factors into x plus a. What was our a? That was our negative 4. So this factors into x minus 4 squared plus 5 equals, what, 25? Well, crud, now it's in the form we like. We said, wouldn't it be nice if it was a perfect square? And yeah, it would be nice if it was a perfect square. So we make it a perfect square. Once we've done that, subtract the 5 from both sides. X minus 4 squared equals 20. Square root both sides. X minus 4 equals plus or minus. Want to reduce this to square root of 5. If you need to review reducing radicals, it's a good thing to Google. But real quick, that's the square root of 4 times 5, and the square root of 4 is 2. So square root of 20 turns into 2 square root of 5. You guys remember how to do that? Or it's in the background somewhere. You might need to review it. That's fine. But then add the 4, and x equals 4 plus or minus 2 square root of 5. Now, what I want to work on tomorrow and probably the next day is, well, probably just tomorrow, is doing this for a couple different purposes, but in more complicated scenarios. We're not going to go too crazy. We'll look at some fairly complicated scenarios, but nothing too bad, I hope. But this way of solving a quadratic by completing the square is really the only method that we have for solving any quadratic. In Math 65, when you learned how to factor, okay, if this was factorable, we could have subtracted over the 9 and said this was x squared minus 8x minus 4 equals 0 and factored that. If this was factorable, we could have solved it that way. But if our answer's got a radical in it, that wouldn't have been factorable. So if it's not factorable, I'm going to argue that this is the only method we have for solving a general non-factorable quadratic. So we're going to play with that tomorrow, look at it in some nastier scenarios, and practice it. But this tool of completing the square is not only hopefully clearly a really powerful tool here, but it's a powerful tool for a lot of different things. A lot of scenarios have that, wouldn't it be nice if this was a perfect square? Perfect squares are handy. And anytime we end up in that situation where wouldn't it be nice if this was a perfect square, if the answer to that is yes, completing the square is going to be a good tool. So practice some completing the square. We'll talk about it more. Do try to upload some image or some thing for the hand-in homework. You've got a bunch of homeworks due tonight. Hopefully you've already done most of them. I'm looking at the grade book. Most of you have gotten most of those. Most of you have most of those most of the way done. But some of you are going to have a busy day. If you have trouble with those or need any help, let me know. Anything I can do for anybody before you trundle off today? All right. Have a wonderful day. And if you do need anything, let me know.